So hello everyone, welcome to my channel. Now in this video we are going to discuss the topic of river crossing concept. Now those of you who are thorough with this theory part, they can skip this part and then proceed to the numerical part. For that the timeline is given here. So now let's start. So now this river crossing concept, suppose this is the river. So this is the top view of the river. Okay, suppose you are observing this river from a drone, okay, from the top, and suppose this W, this is the width of the river, okay, and the river is flowing in this direction. So this vector represents the velocity of the river, okay, and you are at this particular position. This is location A on this bank, and from this you wish to go to B. Okay, now obviously if you have to cross this river and this B is opposite to point A, then obviously if the river is flowing in this direction, you need to go in this direction. Okay, so if you are traveling in a boat, suppose, or if you are swimming, then you need to go in this direction so that the river flow will take you to the point B. So with respect to the river, the boat will be going this direction. So this is velocity of boat with respect to river, or this is also the direction of velocity of swimmer with respect to river. Now to an observer on the ground, suppose here there is an observer and this observer is on the ground on this bank, and if he is observing this boat, he will be observing that the boat is going in this direction. So this is the resultant velocity of the boat. Okay. Now see this is VBR, that is velocity of boat relative to river. VR is velocity of river. This is the actual absolute velocity of river, that is velocity of river with respect to ground frame. This is velocity of boat with respect to ground frame. Okay. So VR is velocity of river, VB velocity of boat. So these two velocities are with respect to the ground frame, the rest frame. Okay, this VBR, this is the velocity of boat with respect to river. Okay, this is velocity of boat with respect to river. And suppose instead of this river, if it is a lake, that is the water is still, so in that case this boat will be going in this direction. So this is also velocity of boat in still water. Okay, see if the river is flowing like this, okay, and if you have to travel in this direction, so obviously you will be going in this direction because the river flow will take you in this direction and finally you will reach here. Okay, but suppose in case the river is not flowing, now if I go in this direction, I will continue to go in this direction. Okay, so that is if the river is not flowing, if the boat goes in this direction relative to the river, so that is also the velocity of boat in still water, because in still water it will go like this. Okay, it is only the river flow, see it is going like this, the river flow it is pushing it, and finally to an observer on the ground, he will observe that the boat has gone in this direction. Okay, so now suppose this angle is theta. Okay, and let us take this horizontal axis as x-axis and the vertical axis as y-axis. Okay, so now in this triangle, this VBR and VR, they have same sense of rotation, and VB has opposite sense of rotation. So we can apply triangle law of vector addition. So we have VB, this is the resultant velocity of these two velocities, because this is in opposite direction and these are in the same sense of rotation. So VB is equal to VBR plus VR. Okay, so this equation I have written using triangle law of vector addition. Okay, so now see, while crossing this river, So the river width is W. Okay. So while crossing this river, the boat, it is undergoing displacement along y-axis. Okay. Displacement along y-axis is W, and it is quite possible that the boat does not reaches here, but it reaches somewhere here or here. Okay. So that horizontal displacement is also there, vertical displacement is also there. Okay. So that means the displacement is taking place both along y-axis and as well as along x-axis. So for displacement along x-axis, we will frame this equation along x-axis. So for motion along x-axis, for motion along x-axis, we can write the x component of velocity of each term. Okay, so this is velocity of river. So this is x component of this velocity, vbx. That means velocity of boat along x-axis. This is equal to vbr. So this is vbrx. That is x component of vbr. And what is vbr? vbr is the velocity of boat with respect to river. Similarly, this is vrx. Okay, so this is for motion along x-axis. Now similarly, for motion along y-axis, for motion along y-axis, I can write the y component of velocity of each term. So that is vby is equal to vbry plus vry. Okay. Achha, now I need to find all those terms from this figure. Okay. See, in this case, river, it is flowing along x-axis. Okay. So the river, see, this is x-axis, this is y-axis. The river is flowing along x-axis. This is the horizontal direction, is the x-axis. So that means vrx is equal to vr, because river, it is already flowing along x-axis. So velocity of river along x-axis will be vr. Now this angle is 90 degree, because angle between x-axis and y-axis is 90 degree. So if this is vr, this component velocity along y-axis, that is vry, it will be vr cos 90 degree. This will be the base component, the cos component. Cos 90 is 0, so that means vry will be equal to 0. Okay, so now we have got the value of vrx and vry. So this value is vr and this value is 0. Okay, now let's see what are the values of other terms. This is vbr, this is vbr, this angle is theta, angle with the vertical. Okay, so this is vbr cos theta and this is vbr sin theta. Okay, so this is the y component and this is the x component of vbr. Okay, but see, this y component of vbr, it is along positive y-axis, but x component of vbr is along negative x-axis. This is the positive x-axis, this is the negative x-axis. So that means this vbr, it will be minus vbr sin theta. vbrx, that is the x component of vbr. This is the x component, this is the horizontal direction x-axis, this is the vertical direction y-axis, minus vbr because it is along negative x-axis. And this vbry, it will be vbr cos theta. Okay, so now let us make these replacements. So we have vbx is equal to minus vbr sin theta plus vr. These are the x component, and along y-axis vby, it is equal to vbr cos theta. Okay, so this is the velocity of boat along y-axis, this is the velocity of boat along x-axis. Now this velocity of boat along y-axis is responsible for displacement along y-axis. Velocity of boat along y-axis will be responsible for displacement along y-axis. So displacement along y-axis is responsible for crossing the river. So while crossing the river, displacement along y-axis is equal to the width of the river, that is w. So if t is the time taken to cross the river, we can write t is equal to w by vby. This is the displacement along y-axis and this is the velocity along y-axis. So this gives t is equal to w by vbr cos theta. So this is the time taken to cross the river. Okay. Now what is this vbx? Vbx is the responsible for velocity of boat along x-axis. Now velocity of boat along x-axis causes the displacement along x-axis. This is x-axis. So because of this, the boat reaches somewhere here, suppose. So this is the directly opposite point and it is reaching this point. So this distance, capital X, this is called the horizontal drift. Okay, horizontal drift is the distance from the point just opposite to the point of starting. So this is the point of starting. The journey has started from this point. This point is directly opposite to point A, but the boat is reaching this point. So this distance is called, this particular distance is called horizontal drift. Now that horizontal drift is caused by this velocity along x-axis. Okay, so this horizontal drift, it is a displacement in this direction along the horizontal direction. So obviously this displacement will be equal to velocity into time. But what will be the time? Time will be the time taken for crossing the river. This is the time for river crossing. Okay, because only for the time during which the boat crosses the river, this horizontal drift will take place. Distance, displacement equal to velocity into time. So velocity is this quantity. So I can write this as Vr minus Vbr sin theta multiplied by time. Time is this quantity. So W by Vbr cos theta. Okay, so this is the expression for horizontal drift. Horizontal drift. Okay, now there are few conditions, important conditions, like this is the expression for time for river crossing. Okay, now if you wish to calculate the minimum time for river crossing, okay, T is W by VBR cos theta. Now if you wish this T to be equal to T minimum, okay, so then you have to see, you can't change W, that is the width of the river. VBR is also a fixed quantity, so only thing can be changed is this cos theta, that is theta. So this for T to be minimum, this cos theta should be maximum. So that is, what is the maximum value of cos theta? Cos theta maximum value is +1, that is theta is equal to 0 degree. So when theta is equal to 0 degree, that is when the boat goes straight across, it will be able to cross the river in the shortest time, and the minimum time will be W by VBR. W by VBR, because cos theta is equal to 1. Okay, so in this minimum time, the boat will be able to cross the river. Okay, now another important condition is, like if you wish to have the zero drift, okay, if you don't want any drift, okay, that means it has to go straight across, that is shortest path. Zero drift means shortest path. Okay, zero drift means shortest path. Okay, so that is, we wish to have this x is equal to 0. So for x equal to 0, we can make this quantity to be 0. Okay, so if you make this quantity to be 0, so that is Vr minus Vbr sin theta is equal to 0. So that gives sin theta is equal to Vr by Vbr, or theta is equal to sin inverse Vr by Vbr. Okay, so this is at, if the boat goes at this angle, if the boat goes theta, this theta, so if the boat goes at this angle, it will be reaching this straight across point. Okay, so these are the fundamental concepts of river crossing. Now based on these concepts, let us try to solve some numericals. So this is a solved example from concept of physics, but we will be trying to solve this question in a different way. This is page number 46, example number 16. So it is given that there is a river This is a river of width 500 meter. Okay, this is the width of the river, and a man can swim in still water at a speed of 3 km per hour. Okay, so velocity in still water is also equal to velocity with respect to river. So this is velocity of man with respect to river, and it is given to be 3 km per hour. Okay, this piece of information is given, and he wants to cross a river that flows at 2 km per hour. So the river is flowing at velocity 2 km per hour. Okay, and he reaches the point directly opposite to his starting point. So he is starting from this point. So since he is going relative to the river in this direction, he is reaching directly opposite point. So suppose this is A, this is B, and this is C. It is given that he is reaching the point directly opposite to his starting point. In which direction should he try to swim? Okay, and how much time will he take to cross the river? Okay, see, just now we have gone through the theory part. So for straight across, if he wishes to reach the straight across point, then for zero drift, we have seen that it is sin theta is equal to VR by VBR. So this is theta is equal to sin inverse VR is 2 and VBR is 3. So this angle, this is theta. So this will be the answer. Directly you can do. Okay, but we are not going to solve like this. See, this angle can be found because this direction is we don't have any problem with this, because he is traveling in this direction and he is reaching straight across. So obviously this will be a right angle triangle. So we can apply the concept of, we can find this angle using either sine function or cosine function. That is not a big deal. Okay, but the second part of the problem where we have to find the value of the time for river crossing. Okay, now time for river crossing is, see, this is 3, this is 2. So this will be this velocity of the boat, it will be in this direction, this 3 square, square root of 3 square minus 2 square. So this is 9 minus 4. So this VB is equal to root 5. So velocity in this direction is root 5. Displacement in this direction is 500. So 500 kilometer. So this is this is kilometer per hour. Okay. So we have to convert this into kilometers. So this is 0.5 kilometer. So time for this crossing, river crossing, will be 0.5 kilometer divided by root 5 kilometer per hour. Okay, so that is T is equal to 0.5 into root 5 divided by 5. So this is 10. So this is root 5 by 10 hour. Okay, so this is the time of river crossing, and this tallies with the what is given in the answer. Okay, but let us see this problem in some another way. See, in this particular case, this is 3, this is 2. Obviously, it is given that since the boat is crossing the man is crossing the river in a straight across path. So along this, the velocity is root 5 kilometer per hour. Okay, so this is VB. Okay, this is basically VB. Okay, now see VMR. This is the we suppose we don't have information about this VB, this information, and this was the information given in the question. Okay, now VMR is velocity of man relative to river, and he is going in this direction. So this is VMR. This is VMR, that is equal to 3 kilometer per hour, and this angle is theta. So obviously this will be VMR cos theta, and this will be VMR sin theta, isn't it? So I can write VMR as VMR cos theta. This is along y-axis, so j cap, and this is along negative x-axis, so plus VMR cos theta minus I cap. So I can write this the vector form of VMR as VMR is equal to, see this is along negative x-axis, so it is equal to VMR sin theta minus I cap because it is along negative x-axis. This is VMR cos theta, so this is along positive y-axis, so VMR cos theta j cap. Okay, so this is VMR. So substituting the values, we have VMR is equal to, this is 3, sin theta is perpendicular by hypotenuse, so it is 2 by 3 minus I cap plus VMR, this is 3, cos theta is base by hypotenuse, so it is root 5 by 3 j cap, so this 3, this cancels out, so we have VMR is equal to minus 2 I cap plus root 5 j cap. Okay, and velocity of river, it is flowing along x-axis, so it is 2 I cap. So as you can see velocity of man relative to river, it is minus 2 I cap plus root 5 j cap, and velocity of river is 2 I cap. So that means the resultant velocity along x-axis, if you see the resultant velocity along x-axis, it is going to be 0 because it is minus 2i and plus 2i cap, this will cancel. So that means the man will have a velocity relative to river only along y-axis, only this component will be left. Okay, so this cancels out, so this is the velocity along y-axis. Okay, and it is for this reason, see the boat crosses the river straight across. Okay, and how much is the displacement? It is 500 meter or 0.5 kilometer. So time taken to cross the river will be 0.5 divided by root 5. So this is into root 5 by root 5. So t is equal to 0.5 root 5 by 5. So that is t is equal to root 5 by 10 hour. So this is another way to approach the same question. So I hope this concept is clear to you. So let us solve one more question. So in another question, you have a river of width 1 kilometer. 1 kilometer, this is the width of the river, and velocity of boat in still water, it is given to be 5 km per hour. So this is 5 km per hour. So this is velocity of boat relative to river, and this is 5 km per hour. Okay, and it is given that this boat crosses the river in a shortest path. The boat crosses the river in a shortest path in 15 minutes. Okay, so obviously if it is crossing the river in shortest path, that means it is going in this direction. It is going in this direction, but the resultant velocity is in this direction, and it is crossing the river in 15 minutes. Okay, so that is time taken is equal to 15 minutes means 1 by 4 hour. Okay, see, remember this width of the river is given 1 kilometer. So that means VB, it will be 1 kilometer divided by 1 by 4 hour. So VB, velocity of boat with respect to ground, it will be 4 kilometer per hour. Okay, so this quantity is 4 kilometer per hour. And in this question, it is asked that what is the velocity of the river? This is VR. Okay, so velocity of boat with respect to river, it is given to be 5 km per hour. It is given that the boat crosses the river of width 1 km in 15 minutes. Okay, and what is the velocity of the river? So these quantities are given, this quantity is asked. So obviously this is a right angle triangle. Okay, and this is a Pythagoras triplet. This is 5, this is 4. So obviously this will be 3 km per hour. Okay, so these are few questions based on riverboat concept, and I have already discussed the concept of river crossing. So I hope this video will be beneficial to you. So if you have any problem, please do comment in the comment box. My best wishes to you. Good luck.